Thank you very much, fellow Kenyans. Once again, I'm Honorable Babu Owino, Member of Parliament in Embakasi East constituency, and a teacher for the KCSE students, part-time teacher for the KCSE students. Today, we want to handle revision, KCSE mathematics revision on a topic called vectors. Stay tuned and kindly enjoy the lesson. And for those who are not interested in enjoying the lesson, then kindly enjoy my suit. Enjoy watching the suit. I will be dispensing knowledge as if I don't care. And I will ensure that our students pass the examination and ensure that our students go to various universities in the country. For education is the key to success. Welcome and enjoy vectors. So. So, our lesson is on vectors. So here we will be dealing with vectors. Vectors is a very familiar topic to our candidates. Vectors is taught from the lower level at the secondary education in high school. And for those who are in Form 4, I can assure you that vectors is one of the topics that will never miss in the KCSE examination. It will come in paper 1 and also in paper 2. It will never miss, and mark my word, this will never miss. So just concentrate, and I'm very sure that we will be adding marks as we proceed, as time passes by. So vectors, from the definition, vectors, a vector is a quantity that has direction. It has both direction and also length. So vector is a quantity that has both direction and has length. So if we have a line segment, if we have a line segment AB, the line segment is denoted by that, to mean that this is a line segment AB. While in vectors, we want to denote vectors. So when you are denoting vectors, it can be denoted by AB, then a line and an arrow like that, or AB and a wavy line or a curvy line below it, or AB and a wavy or a curvy line at the top of it. So from here generally, this is just ways of denoting vectors. That is AB and an arrow, AB and a curvy line, and then AB and a curvy line at the top. Then immediately we can go to, we want to know these types of vectors that we are dealing with, and before that we can talk about displacement of vectors. Displacement of vectors. I will combine this together with getting the position vector and also the column vector. So when we are dealing with displacement of vectors, if we draw on a Cartesian plane, this is our Cartesian plane, x-axis and y-axis. So on our Cartesian plane, if we have a point A with the coordinates 3, 4, from the origin O, then point OA is denoted by a line and in that direction, OA, moving in the direction of OA. So OA has a position vector A, letter small letter A. So OA is moving in the direction of O to A with a small letter A. Then OA has vector OA has a position vector A and has a column vector. When you're writing 3, 4, this is in the form of a coordinate. But when you're writing it in form of a column vector, it is 3, 4. So vector OA equals to the position vector A equals to the column vector of OA, which is 3, 4, written in this form, in a column form. So after that, we go to the displacement. Displacement of vectors. And displacement of vectors is also called, the displacement is also called the modulus of a vector, is also called the magnitude of a vector, and is also called the length of a vector. So when examination is set, they can either use any of the terms here. They can use displacement, modulus, magnitude, or length of a vector, and is denoted by 2 parallel lines like that. So from our Cartesian plane, if we have our coordinates 3, 4, and we want to find the length of this vector, the modulus of this vector, the magnitude of this vector, or the displacement of vector OA, simply just drop this down. It's a very simple one. Then there we form a right angle triangle. Then 3, 4 means there are 3 units moving, 3 units to the x-axis, and then 4 units to the y-axis. So this is 3, 4, the coordinates 3, 4. 3 units to the x-axis, then 4 units to the y-axis. Then what we are forming here is a right angle triangle. By Pythagoras theorem, we say that hypotenuse squared equals to base squared plus height squared. Therefore, in our case, our base squared, hypotenuse squared, equals to base squared plus height squared. So our hypotenuse alone is equal to, make h the subject of the formula, h equals to the square root of base squared plus height squared. Therefore, h equals to our height equals to base squared is 3 units, which is 3 squared, plus height squared is 4 squared, or into the square root. So h equals to 9 plus 16 into the square root. This is the square root of 25. H, which is the hypotenuse, is equal to 5. So you write as 5 units. You don't leave it naked. You have to include the units. So that is 5 units. So in other words, our modulus for a vector OA is given as base squared plus height squared into the square root, that is 5 units. So from here, this is very easy. When we want to now get OA, you write it as OA modulus, which is equal to 3, 4 modulus. So from here, class, it is an easy one. If you don't want to use this formula, you just come here and square 3. You say 3 squared, then square 4, 4 squared, then into the square root. This gives you vector OA, the modulus of vector OA, or the length. This gives you 25 into the square root, which is equal to 5 units. So another example, if you are given a vector OB, having a column vector 6, 8, then you are told to find the modulus or the magnitude of this vector. So this one is just simple. It will be OB. Make sure you include this sign. This sign means magnitude or the length or the size. Then you simply say this 6, 8. This equals to OB equals to square 6 plus square 8. Then just find the square root. So when you get this is 36 plus 64 into the square root. This is the square root of 100, which is equal to 10 units. So from here, that one is all about the modulus, all about the displacement. Simply square this plus this squared, then to the square root. Then we want to go to a unit vector. Vectors in the form of I, j, and k. We call them unit vectors. These are vectors in the form of I, j, if it is in 2 dimension, and in 3 dimension, I, j, and k. So modulus here also, when you are given in 3 dimension, if I may just come up a little bit, if you are told that you have a value like let's say a point OC, vector OC, not a point, vector OC has coordinates of 2, 3, has not coordinates but has a column vector of 2, 3, and 4. But a point C has coordinates of 2, point C has coordinates of 2, 3, and 4. Written as a column vector of 2, 3, and 4. So when you are told to find the modulus of this, it's simple class. We say OC modulus equals to 2, 3, 4 modulus. So you simply square 2 plus 3 squared plus 4 squared all into square root. 2 squared is 4 plus 9 plus 16 into the square root. This comes to the square root of 29 units. So you make sure you get the square root of 29 from your calculators, which should be 5 point something. So then we come to the unit vectors in the form of I, j, and k. So here, when you are given vectors in the form of, if you have a vector OA, which is 2, 1, 2, 1, then you are told to write this vector in the form of I, j, and k, or in the form of I and j. If we start with 2 dimension, then we go to 3 dimension. So this OA means that the point A has coordinates of 2, 1, and the column vector is 2, 1. So when you are writing in the form of I, j, and k, from our Cartesian plane, this is the x-axis, this is the y-axis, and this is the z-axis. At this point is a right angle triangle, right angle point, and at this point is also right angle. So if it is 2 dimension, is only in the x and y axis. So write this in the form of I and j. The first value, which is the x value, this is the x value and this is the y value. X value takes I, y value takes j. Then if it is 3 dimension, z value takes k. So write this in the form of I and j. So this comes to, in the form of I and j, you simply write 2 I, you add I there, then plus, you take 1 with its sign, which is a positive, silent positive, plus 1 j, which is the same as plus j. That is 2I plus j in the form of, this is a unit vector in the form of I and j. If we have another example, example 2. If we have 2, 4, 5, a point B has coordinates 2, 4, 5. So OB, the vector OB in column vector form is 2, 4, 5. In the form of I, j, and k, this is now in 3 dimension. You simply introduce 2, then take I, 2I plus 4j plus, the last one is 5k. This is the form of I, j, and k. What if it is a negative, an example with a negative sign? Let's say we have 4 minus 2. a point 4 minus 2 minus 1. Point D. So in the form of ijk, you just say 4I, then take 2 with its sign, becomes minus 2j, then take 1 with its sign, becomes minus k. Okay? So we can have so many examples on this. Suppose you are given a point z as 2, if you are told 2i minus 3j plus 4k. This is a unit vector, OZ is that. Therefore, from here, our column vector is 2. You take 3 with its sign minus 3, and then 4 with its sign 4. So the unit vector is very easy to play around with. You just introduce I, j, and k, where there is the x value takes I, y value takes j, and z value takes k. So you can be told that you find the modulus of this. So in finding a modulus of this, this is OZ, modulus, that is the sign, OZ equals to the modulus of this. You write it in column vector form, which is 2 minus 3, 4. Then you introduce the signs. So this is simple, just square 2 squared, plus take 3 with its sign, minus 3 squared, plus 4 squared, everything square root. This becomes 4 plus 9 plus 16 into the square root. This is the square root of 29. Then in units. So I think this is as easy as that. Vectors is very easy, just concentrate. I normally tend to make these topics as easy as possible, as digestible as possible, so that when you face your exams, you face it with a lot of ease. So after the unit vectors, we go to the linear combination. We go to the linear combination of vectors. Linear combination of vectors. So from here, let's start paying serious attention, class. A linear combination of vectors, you can be given points P as 5, 3, point Q as 2, 1, and point R as 4, 3, as 4, 2. Then you are told to write P as a linear combination of Q and R, or Q as a linear combination of P and R, or R as a linear combination of P and Q. Now, in such a situation, do not panic, just write P, vector P, transform this into vector form. So the position vector of OP is P, denoted by that, equals to, introduce a scalar T, scalar T of Q, the position vector of Q, plus a scalar H of R. Plus again, if you're given such a challenge, just write P in terms of Q and R, but introduce scalars. So P is a linear combination of Q and R. But you don't leave it at this point, you solve it. So you come down, write vectors of P in column vector form is 5, 3, equals to T, then Q is 2, 1, plus H into R is 4, 2. Then you open this up, this will form a simultaneous equation. So when you open this up, this is 5 equals to, the upper one takes the upper values, then the lower one takes the lower values. So 5 is equal to 2 times T is 2T, plus 4 times H is 4H. Then the lower one takes 3 equals to t times 1 is t plus 2 times h is 2h. Then solve this by elimination method or substitution method. So let's use elimination method to solve this. This is 5 equals to 2t plus 4h. Then 3 equals to t plus 2h. So by elimination method, we multiply both. We multiply the down one by 2 so that we make this to be equal. So this is going to be 5 equals to 2t plus 4h. Then this is going to be 2 times 3 is 6 equals to 2t. 2 you multiply by everything here plus 4h. Actually, I've used an example that is giving everything as 0. So we can take another example. We will use the same method, but because our value is coming to 0 and this is coming to 0, so we can just take another example. Let's change this value for r. There is no mistake made. It's only that these values are all coming to 0. So when it comes to 0, because I'm using the examples offered, so we can change this to be even 5, 16. So the same method, I just want you to follow it here closely. Just use the same method. P equals to T 21 of Q is here, plus H of R. So our R is 5, 16. So here, open it up. Our P value is 5,3 equals to T of 21 plus H of 5, 16. So open it up. 5 equals to 2 times T is 2T plus here is 5H. Then 3 here equals to T plus 16H. The same thing, 5 equals to 2T plus 5H. Then 3 equals to T plus 16H. Then by elimination method, multiply by 2 so that we make them equal. This is going to be 5 equals to 2T plus 5H. Then this is going to be 6. 2 by everything here, 6 equals to 2T plus 32H. Then by elimination method, you subtract. Remember, when you are subtracting on this side, you are getting everything as 0. So which means that the value that I used here is not applying to this. So I've changed the value. That's why it's coming out. So this minus this, subtract everything. This minus this is 0. 2T minus 2T is 0. 5H minus 32H. 5H minus 32H is minus 27H equals to 5 minus 6 is minus 1. Then divide everything by minus 27 minus 27. So our value for H is equal to 1 over 27. So we found our H value. What about our T? So you just come and substitute. You say here 3 equals to T, but our is equal to T plus H, which is 16H. So 3 equals to T plus 16, but our H is 1 over 27. So this is going to be, let me cross this. This is going to be T equals to 3 minus 16 over 27. So LCM is 27. Then 1 goes into 27. 27 times 3. That is 21 carry 2. That is 81 minus 16. So this is going to be 81 minus 16. That's 5. That's 65 over 27. So our T value equals to 65 over 27. Irrespective of whatever value you are getting as your t and as your h, do not worry about it. It doesn't matter. So after getting our h value and t value, you come to your initial equation, which is here, class. So from this initial equation, just replace, concentrate here. So write P in terms of T. Our T value is 65 over 27 of Q, plus our H is 1 over 27 of R. So this is P as a linear combination of Q and R. So Q can also be found as a linear combination of P and R. So let's take another example, because let's take just another example, one more example of linear combination, example 2. So let's take a point A has coordinates 5, 6, B has coordinates of 2, 3, and point C has coordinates of 4, 7. So let's express A as a linear combination of B, C, or let's express B as a linear combination of A and C. So we say B, denoted by that, equals to T of A plus H of C. So you just come here, replace values for B is 2, 3, equals to T of A is 5, 6, plus H of C is 4, 7. Then open this up, you get 2 equals to 5 times T is 5T plus 4H. When you open this, then down one is 3 equals to 6T plus 7H. Then from here, we can multiply both sides by, we can multiply by 6 and by 5, and by 6. Okay, from the next one, to make your work look neat, 2 is equal to 5T plus 4H, 3 equals to 6T plus 7H, then multiply here by 6 and multiply here by 5. You just interchange this, or either multiply by 4 and 7 or 6 and 5. So by elimination method, this is going to be 12 equals to 6 multiplied by everything here, then 5 multiplied by everything here. So this is going to be 12, then equals to 30T plus 24H. Then down here is going to be 15 equals to 30T plus 35H. Then by elimination, 30T minus 30T is 0. Then 24H minus 35H is minus 11H equals to 12 minus 15 is minus 3. So divide everything by minus 11 by minus 11. So H becomes 3 over 11. So when H is 3 over 11, when H is 3 over 11, get the value of T. So you come and substitute it here. So you say 3 equals to 60 plus 7H, but 7H, okay. So 3 equals to 60 plus 7, but our H is 3 over 11. Therefore 60, when you make 60 the subject of the formula, you bring this the other side, so this becomes 3 minus, when you multiply this is 21 over 11. So after that, find the LCM here. 60 equals to, LCM here is 11, then this is over 1, 1 goes into 11, 11 times 3 is 33, minus 21. So this is going to be minus 21, this is 12 over 11. So 60 equals to 12 over 11. Divide everything by 6, this side also by 6. So T equals to, here once, here twice, is 2 over 2 over 11. Then from here, come to your initial equation. Just replace it. B equals to T. Our T value is 2 over 11 of A, plus H. Our H value is 3 over 11 of C. So this is B as a linear combination of A and C. Then I want you to note something from the previous example and this example. The conclusion that I want to make here is very simple. When you take this fraction, and you add to this fraction, if it gives you 1, in our case, this is 66 over 27, it does not give us 1. If it gives you 1, then this is the conclusion that you'll make. So the first one does not give you 1. The second one also is 2 over 11 plus 3 over 11 is 5 over 11. So it means that the points that we had are not on the same line. So if we have a point A, B, then a point C can be somewhere there. They are not on the same line. But if the fractions add up to 1, then it means that A, B, and C are on the same line. Okay? So that is the conclusion that we can make on that. Then we talk about parallel vectors. Parallel vectors. If you are given two vectors, A and B, and then parallel to vector C and D. So vector A and B is parallel, that is the sign for parallel, to vector C, D. But what is the condition? Vector AB can only be parallel to vector CD if it is a multiple of CD. Class. Parallel vectors, we have vector A, B, and vector CD. So vector AB is parallel to vector CD. But what is the condition to prove that they are parallel? So vector AB can only be parallel to vector CD if it is a multiple of CD. Or vector CD can only be parallel to vector AB if it is a multiple of AB. So I will combine this with collinear points by giving examples. Then you see how I solve the questions and it will ring a bell. So we go to collinear point. Just put this at the back of your mind. We are going to use it down here. So collinear points. Collinear points means that if we have a vector, if you have points A, you have a line, point B, point C. So if a point A has the coordinates of -2, -2, 2, 1, and 10, 7. These values I'm just using them offhand to prove that they are collinear. So if we have a line ABC with the points A to -2, -2, point B 2, 1, and point C 10, 7, then you are told to prove that point A, B, and C are lying on the same line. Collinear means they lie on the same line. So for them to lie on the same line, you will prove two things. The first thing that you will prove is that they are parallel. And when they are parallel, this line is parallel to this line. So for example, line AB is parallel to line BC because they are moving in the same direction. That means that they are parallel. Okay? So, number one, we prove that they are parallel. So when they are parallel, we say AB is parallel to BC. So, but when AB is parallel to BC, we say that AB must be a multiple of BC. You introduce a scalar multiple of BC. Therefore, AB, vector AB, what does AB means? Let me take you back a little bit, just a little bit, to tell you what AB means and what BC means. So if you have a Cartesian plane, and you have a point A, let's say OA, and then a point B. So from the origin the position vector of OA is given as A, while the position vector of OB is given as B, in that direction. So how do we get AB vector AB? AB, you move the way it's moving. AB, that direction must be shown. When you are using vectors, you must show the direction. So OA is denoted by A. OB is denoted by B. What does AB means? AB means you can move from A to B direct, or you can move from A to O, then O to B. So when you move from A to O, you are moving in the opposite direction. Remember, OA is A. Therefore, AO, if OA is equal to A, what about AO? Opposite direction means negative A. Therefore, AB, vector AB equals to AO plus OB. So AB, vector AB equals to AO. AO, you are moving in the opposite direction, which is negative A, plus OB, which is B. So when you write this nicely, vector AB equals to B minus A. So class, when you are told AB, AB means B minus A. BC means C minus B. Okay? So AB means B minus A. BC means C minus B. So you just replace it by the coordinates. And but you write it in the column vector form. So AB means B, but our B is 2, 1. Minus A, our A is minus 2, minus 2. Equals to T of BC. But BC means C, which is 10, 10, 7, minus B, which is 2, 1. So 2 minus minus 2 is 4. 1 minus minus 2 is 3. Equals to T into 10 minus 2 is 8. 7 minus 1 is 6. So when you open this up, 4 equals to 8T. Whereas 3 equals to 6T. So T equals to, you can either use this or this, equals to, divide both sides by 8 becomes 4 over 8. And this other side, T equals to 3 over 6. So this is a half, this is a half. So in both cases, you get your value of T as half. So you just come here and replace. I want to do something here. So from here, we said AB is parallel to BC. And we said AB equals to T of BC. Therefore, AB equals to T, but our T is half of BC. Okay? So, the conclusion, from here, we have, you identify a common point. This is, you've already proved that AB is parallel to BC. They are moving, they are on the same line. The next, you identify a common point. So we have AB and BC. So B is common. Then you say B is a common point. Therefore, A, B, C are collinear. Okay? So to prove collinearity, that these points are collinear, that they lie on the same line, then you have to prove that 2 points are parallel to each other. Then after that, after proving that they are parallel to each other, then you identify a common point, which is point, in our case is point B. Then you make a conclusion that A, B, C are collinear. Another example, Just from the same example, you can also use, we said our A. From the same example, we said our A, B, C. Negative 2, negative 2, 2, 1, then 10, 7. From the same example, we used AB and BC. So we can use AC, we say AC, vector AC is parallel to vector BC. So in our case, second situation, you see C is the common point. So depending on whichever you use, but let's get our value of T. So we said when they are parallel, then AC is a multiple of BC. So our AC means C minus A. So C minus A is 10, 7, minus A is minus 2, equals to T of BC. BC means C minus B. So C minus B is 10, 7, minus B is 2, 1. So 10 minus minus 2 is 12. 7 minus minus 2 is 9. Equals to 10 minus 2 is 8. So this is 8T. And then this is equal to 7 minus 1 is 6T. Okay, this into T. Let me make my work neat. So this is when you take the upper part, 12 equals to 8T and 9 equals to 6T. So divide this by 8. So T here is equal to 12 over 8. 2 here, 4 here, 2, 4 here, 3. So T is equal to 3 over 2. Let's see here. Divide everything by 6. So 9 over 6 equals to T. 3 here 2, 3 here 3. So T here again is equal to 3 over 2. So you can see we are getting the same value of T. Therefore you write as AC equals to T, which is 3 over 2 of BC. Then you identify a common point. This is a marking point. Then a common point is point C. You say C is a common point. Therefore, A, B, C are collinear. Very easy, class. So we take one more example because this collinear is also, and believe me, it will also come in examinations. So let's take one example for collinearity. Let's say a point A. Let's say a point A as let's take one example with 3 dimensions. So 3 dimension, point A is 7, 20, then minus 3. Then a point B, let's say is 1, 2, 3. Then a point C, let's say is 3, 8, 1. So point A, point B, point C. Prove that that line A, B, C are collinear. So the first thing you say, you prove that they are parallel. So to prove that they are parallel, you say AB is parallel to BC. So, but what does AB equals to? Introduce a scalar of BC. The scalar multiple of BC. But AB means B minus A. AB means B minus A. So AB means B, which is 1, 2, 3, minus A. A is 7, 20, minus 3. Equals to T into BC means C minus A. So C is 3, 8, 1, minus B. Our B is 1, 2, 3. So when you open this up, 1 minus 7 is minus 6. 2 minus 20 is minus 18. 3 minus minus 3 is 6. It's the same as 3 plus 3 is 6. You be careful with the signs. Then this side we have T into 3 minus 1 is 2. 8 minus 2 is 6. Then 1 minus 3 is minus 2. Open up. take the values. Minus 6 equals to 2t. The first value takes the first value. Second value is minus 18 equals to 60. Third value is 6 equals to minus 2t. Let's see if these t's are the same. So from here, you divide everything by 2 by 2. So from here, t equals to minus 6 over 2. Here, t equals to, divide by 6 is minus 18 over 6. Then here, t equals to 6 over minus 2. So here, t is equal to minus 3. T is equal to 6 divided by 18 is minus 3. And this side, t equals to minus 3. So you will just know that you are getting the right answer if you are getting something which is the same. Therefore, you say that AB equals to t, our t is minus 3, of BC. Okay, that is 1. 2, you say B is a common point. In these two cases, B is a common point. Therefore, A, B, C, line A, B, C are collinear. Very easy. At the university level, when they do about parallel vectors or collinear vectors, they will also add something called orthogonal vectors. Orthogonality means perpendicular vectors. If you come from the lakeside like myself, you become proud of your English. So instead of saying perpendicular, you say orthogonal. So another one, we go to, after that class, we go to proportional division of a line. Proportional division of a line. So in proportional division of a line can be divided into two. One, a line can be divided internally. And two, a line can be divided externally. So let's start with the first one, internal division of a line. So in internal division of a line, let's say we have a line AB. Line AB. And we divide it into 4 units. 1, 2, 3, 4. 4 portions. 1, 2, 3, 4. So from here, class, and this will come in your examinations. And these will come in your examinations. I can say without an iota of doubt. So you must concentrate here. And majorly, this two comes as a 10-mark question. 10-mark question. So when you concentrate here, you already have 10 marks. You're already moving from E, from elephant. You are going to A, apple. You see how they are inversely proportional. Elephant is bigger, apple is smaller, but in examination, apple is bigger than an elephant. So now here, let's say we have a point P, a point X, and a point Y. Just pay attention. Then we pick only one point. These are equal division, one portions each. So let's take, for example, a point P. A point P divides line AB in the ratio of 1 is to 1, 2, 3. In the ratio of 1 is to 1, 2, 3. So if I draw it afresh and say this is A, this is B, then I put my P here. Then we have other units there. So a point P divides line AB in the ratio of 1 is to 3. So you say A to P ratio P to B equals to 1 is to 3. If we take X, so we'll say X divides line AB in the ratio of 1, 2 is to 1, 2. You just where X is, so you divide it into those ratio form. So at this particular point, we want to find the position vector of P. When you mention the word position vector, make sure you join it to the origin, which is point O. Origin is 0, 0. So on our Cartesian plane, this is point A. So you move OB is denoted by position vector B, OP is denoted by position vector P, and OA is denoted by position vector A. While AB moves in that direction. AB moves in that direction. Therefore, class, you are told to find the position vector of P. But P is divided in the ratio of 1:3. So, position vector of OP is P. So, we say OP, if we want to get O to P, how can we move from O to P? If we want to move from O to P, you can take this route. O to P can be equal to O to A plus A to P. Again, O to P is equal to O to A plus A to P. So, OP equals to OA. OA is given by A plus AP. AP is given by, that is now why we were introducing the ratio. So it's given by this ratio, which is 1, divided by the total ratio here is 4. Total ratio is 4. So 1 divided by 4 of AB. Okay? So OP, don't get lost. I think some may be saying I'm getting lost. Now, OP is equal to OA plus AP. OP is equal to OA plus AP. But OP is equal to OA is A here plus AP is, now you make use of the ratio. This side has 1 over the total ratio, which is 4. From here to here is 1, is 2. From here to here is 3. So it is 1 over the total ratio, which is 4, of AB. Of AB. So this is going to be A plus a quarter, 1 over 4 of, I told you AB means B minus A. So, or you can simply come here and say, how do I move from A to B? So, AB, if you want to move from A to B, you can take this route, reach Kericho, then from here to here, reach Kisumu. You're going to Kisumu. So you come, you can either go direct, or you can go like AB is equal to AO plus OB. So AB equals to AO. AO, if OA is A, AO is, you are going in the reverse direction, so it is minus A. Plus OB is B. Therefore, AB equals to B minus A. So you just come and replace it here. AB is B minus A. So OP equals to A, open the bracket. If you open this bracket, a quarter times minus A is minus 1 over 4 A. Then a quarter times B is plus 1 over 4 B. So when you solve this, OP equals to A minus a quarter A is 3 over 4 A plus a quarter B. So that is your position vector OP. Let's do for X, and then I will tell you how we get for Y using a very simple formula. So for X, X divides line AB in the ratio of 1, 2 is to 1, 2. So we say we have A and B, then it's subdivided into 4 units. Then our X is here. So X divides AB to AB in the ratio of 2 is to 2. So which means that AX to XB equals to 2 is to 2. 2 is to 2 is the same as 1 is to 1 when you simplify the ratios. Therefore, the position vector of X How do you get position vector of x? Just make an origin point because we want the position vector of x. So OX, this is our center O. So OX is small x, that. OB is B. And then OA is A. Therefore, OX, remember this line is running like that. So OX equals to OA plus AX. But OX equals to OA is A plus AX. AX is 2. The total ratio here is 2. So 2 is to 2 is the same as 1 is to 1 when you simplify the ratio. So it is 1 divided by the total, which is 2, of AB. So OX equals to A plus a half. AB, I told you, means B minus A. So here becomes A. Then when you open the bracket, plus a half times minus A is minus a half A. Then a half times B is plus a half B. So when you simplify this, becomes a half A plus a half B. So class, that is OX, position vector of OX. So I want us to derive a formula. Then we will use this formula to ease the work instead of going through all this. So in our formula, pay attention here. So here, let's say we have a line A, B, but it's divided in the ratio of M is to N. So if this is our point, let's say this is our point Z. So AZ ratio ZB is equal to M ratio N. So when you add these two ratios, the total ratio becomes M plus N. Keep that. This is the total ratio. Keep that at the back of your mind. Therefore, we want to get position vector of Z. So position vector of Z, same thing. This is our point O. Remember, OA is A, OB is B, then OZ is Z. This line runs from A to B. Therefore, OZ equals to OA plus AZ. OZ equals to OA is A here plus AZ. AZ is M, the ratio, divided by the total ratio, which is M plus N, of AB. Therefore, OZ equals to A plus M over M plus N of AB means B minus A. AB, you move minus A plus B, which is B minus A. Then open this bracket and solve it, simplify. So when you simplify, this comes to OZ equals to, this is going to be A plus B times this is MB over M plus N. Then this M over M plus N times A times minus A is minus MA over M plus N. So you simplify this because we have A here and we have A here. Bring them on one side. So A minus MA over M plus N. How do we simplify this? LCM is M plus N. Then over 1. This goes here M plus N times. So it becomes A into M plus N minus MA. further open this, A times M is MA plus A times N is ANA minus MA divided by M plus N. MA minus MA is 0, therefore we remain on this side with only NA over M plus N. Remember, we were solving this. We were solving this and this, but we have this. So when we have this, you add it to, so our final answer, OZ, equals to this, NA over M plus N, plus, this is MB over M plus N. So class, this is what we call the ratio theorem. Ratio theorem. So why am I interested in deriving this? Because it will help you in solving, simplifying your work. So this ratio theorem, from here, ratio theorem, from here we have NA over M plus N plus MB over M plus N. So how does this help us? This ratio theorem. So if we have our line, I want to prove to you something here, AB. Then remember our first value, this is divided into 1, 2, 3, 4 units. Then we had our first value as P, then X, then Y. So P, we said it divided this line AB in the ratio of 1:3. So if we were to get the position vector OP, then we said this is O, OB is B, OP is P, OA is A. So instead of going OP, which is equal to OA plus AP, we simply use the ratio theorem and we say our ratio is 1:3. Then we want to, we have A and B, the line AB. So this point P divides line AB in the ratio of 1:3. So ratio of 1:3 divides that line AB. So the ratio theorem, class, concentrate here. This value takes that A and 1 takes B. Again, if it is divided in the ratio 1:3, just write this ratio is along the line AB. Divides this line in the ratio of 1:3, that is point P. Therefore, just write AB, then 3 takes A, 1 takes B. So how do we get our answer without going through all that calculation? You say 1, which is the ratio 1 over the total ratio of B. What is B? B is here. Then here plus 3 over the total ratio of A. What is A? Position vector is A. Therefore, this is our OP. As simple as that. Now, we have another one for X. AB. We said this is our X. X was dividing this line AB in the ratio of 2:2, which is the same as 1:1. So we say 2:2 divides line AB. So this takes 2 takes A and this other 2 takes B. Therefore, the total ratio here is 4. So just say 2/4 of A, of 2/4 of B plus 2/4 of A. This is our position vector OX. So this is a half B plus a half A. You remember we got an answer like this from the previous example. So that is dividing a line internally. Now we want to go to dividing a line externally. External division of a line. I want to make this so easy because external division of a line has proven to be giving some students a nightmare. But when you are in my class, the last student shall score 70%, which is an A. The first student can score 100 star, 100 plus if there is any plus. That means that that paper, you are disappointed by the examiner. When you get 100, which means that you are really disappointed by the examiner. So which means that you should be the examiner. Now, external division of a line. Let's say we have line AB divided into 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So if we have not B, let's say we have our B here and our P here. So class, I want you to concentrate here. We have our line AB, but we have a projection. We have an extension of line P. So P divides line AB externally. P divides line AB externally, outside AB. It divides it externally. Extension, extending externally. Okay? So P divides line AB in the ratio of 1, 2, 3, 4, 5, 6, 7. Ratio. Now remember 1, 2, 3, 4, 5. So I want you to pay attention here. P divides line AB externally in the ratio 7:5. But if you don't use the word externally, so exam can tell you externally or exam can tell you that P divides a line AB in the ratio this is to this. So we want to see that. So this can also be expressed when you use 7:5, then which means that this P divides a line AB externally. We can also say that P divides line AB in the ratio of 7:5. Remember, I've not used the word externally because I've put negative here. We say that P divides line AB in the ratio of 1, 2, 3, 4, 5, 6, 7. Remember, this line is moving that way. But PB, you are moving reverse. So when you are coming reverse, 1, 2, 3, 4, 5. So when you are coming reverse, you include the negative sign. I hope you've understood that. I'll give you an example again, but let's finish this. So when you are given this, just smile and say that you are the examiner. So this is the ratio of 7:5. So when we use our method to get, this is O, to get P, this is P, this is OB is B, OA is A. So we want to get the position vector OP. Position vector OP. So OP is equal to OA plus AP. Remember, OP is equal to OA plus AP. I want to reach this point. So how do I reach? Like this. And plus AP. Pay attention. OP equals to OA. Our OA is A plus our AP. Our AP is the ratio 7 over the total ratio. Total ratio of this and this is 5 plus minus, is 7 plus minus 5. 7 plus minus 5 is 2, which is 7 minus 5. Total ratio is 2. of AB. Very easy. So OP equals to A plus 7 over 2 of AB, I told you, means B minus A. AB is B. AB is minus A plus B. Minus A plus B, which is B minus A. So when we open this up, OP equals to A, then 7 over 2 times minus A is minus 7 over 2A, plus, you open with this, 7 over 2B. Then find LCM for this. Just solve this. Is 2. Then this is 2A minus 7A plus 7 over 2B. So 2A minus 7A is minus 5 over 2A plus 7 over 2B. So this is the position vector OP. Remember the ratio theorem? Without going through all this process, the ratio theorem, write your ratio here, 7 is to minus 5. Then divides line A, B. Okay? Then I told you that P divides line AB in the ratio of 7 is to minus negative 5. It divides this line. So this takes A and this takes B. So OP equals to, when you start with this, is 7 over the total ratio is 2 of B. Then you come to this, you take it with its sign, minus 5 over the total ratio is 2 of A. This and this are the same. Minus 5A plus 7 minus 5 over 2A plus 7 over 2B is the same as, when you write this sweetly, becomes 7 over 2B minus 5 over 2A. So this and this are the same. So you see the way the ratio theorem makes work so easy. So that is external division of a line. Now, I don't know how much time we've taken. If I can do some few examples. Huh? We've taken like 1 hour? 1 hour, 15 minutes. So class, just give me another 15 minutes. I do some revision on some questions on vectors. We finished our class as easy as that. So, or, no, let me handle some few questions. In the next 15 minutes, let me just handle some few questions. So I have questions here that I collected from KCSE revision or the past papers. So pay attention. I'll be reading as we'll be solving. So question number 1. We finished the class, and it's as easy as that. So question number 1, you are told, given that 4P minus 3Q equals to 10, 5, and P plus 2Q equals to minus 14, 15. Find 1, P and Q. So when you are told to find P and Q, remember this question has been given more or less the same as it is a simultaneous equation. So you just solve this simultaneously. When you are solving this simultaneously, do not panic about this other side, because normally you are used to only one number. So here you are given a column vector. So do not panic. Just come and solve by elimination method. So 4P minus 3Q equals to 10, 5. Then here P plus 2Q equals to minus 14, 15. So by elimination method, we can decide to multiply both sides by 4. We multiply the downer part by 4, this 4. So this is going to be 4P minus 3q equals to 10, 5. Whereas this is going to be 4p. You open up this. So this is going to be 4p minus, no, plus 4 times 2, q is 8q, equals to, then 4 must multiply both these two values. So 4 times this is minus 56. Then 4 times 15 is 60. Then normally the way you just handle substitution equation, simultaneous equations, you subtract. So from here, this minus this is 0. Then minus 3q plus minus 8 is minus 11q equals to, then we subtract this minus this. So when you're subtracting this minus this, the first one will minus the first one. So 10 minus 10, so this is going to be 10, 5 minus 56, then 60. So this is going to be minus 11q equals to 10 minus 56 is 66. Okay? And then 5 minus this is 50, is minus 55. Is it? You be careful with the signs. Signs. 10 minus 56 is 66. Good. 5 minus 60 is minus 55. Good. Therefore, q, when you are getting q, divide everything by 11. By 11 minus 11. This side also 66 divide by 11. And then minus 55 divide by 11. So 11 and 11 goes. So q equals to 66 divided by 11 is 6. While minus 55 divided by 11 is minus 5. So that is your value for q. So what is your value for p? Substitute here. So p plus 2q equals to minus 14, 15. So p plus 2 times q is 2 into 6 minus 5 equals to minus 14, 15. Therefore, p plus, this is 12. 2 times 6 is 12. 2 times minus 5 is minus 10. Equals to minus 14 over 15. So here p equals to, when this crosses the other side, becomes a minus. So we have minus 14, 15. Then this one becomes minus 12, minus 10. So this becomes minus 14 minus 12 is minus 26. Then this is 15 minus 10 is 15 plus 10 is 25. Therefore, the value of q is this, and this is the value of p. And that's the value of p. It is just p and q, not in vector form. So as easy as this, these are the applications. Then class, there is one thing that I've just remembered that comes so frequently, just an application of division of lines, proportional division of a line. So in this, pay attention here. I've just remembered it before I go to another question. But I think I can just do it, then we can revise questions in the next lesson. But concentrate on this. This must come in exam. This must come in exams. So, A, B, concentrate here, class. So you are told that a point X divides the line AB in the ratio of 2:1. While a point M divides, this is O, divides line OB in the ratio of, let's say, 3:4. 3:4. Then you are told that this line AM and OX intersect at a point Z. Very interesting, very nice. This must come in exams, I can promise you. Not necessarily the same ratios, but the same style of setting. So, you are told AX ratio XB to XB equals to 2:1. And then you are also told here OM to MB equals to 3:4. Then this is OB means that, then OA means that. OA is A, OB is B. Then AB as usual means B minus A, which is B minus A. So OZ, you are told to find the position vector OZ. OZ. So OZ moves in that direction. Therefore, OZ is a scalar. You say OZ, concentrate here class, OZ equals to a scalar T of OX. OZ, you want the position vector OZ. So OZ equals to a scalar of OX. But what is OX? So OZ equals to, one way of getting moving to point OZ is by using a scalar of OX. So OZ is equal to T of OX. But what is OX? Our OX is OA plus AX. Our OX is given by OA plus AX. So OZ equals to T of OA is A plus AX. AX is 2 over the total ratio, which is 3 of AB. We'll also use the ratio theorem, you'll see how it's coming out. So OZ equals to T of A plus 2 over 3 of AB, but AB is B minus A. So OZ equals to T into A. Then when you open up this, 2 over 3 times minus A is minus 2 over 3A plus 2 over 3 of B. So open this up, OZ equals to T into A minus 2 over 3A is a third A plus 2 over 3 B. Then further open it up, OZ equals to, multiply everything by T. This is a third TA plus 2 over 3 TB. So plus 2 over 3 B. Now that is one way of expressing O to Z. Another way of expressing O to Z, you say OZ O to Z, you can also take this root and take it from here. From here you say OZ is OA plus AZ. So OZ equals to OA is A plus AZ. What is AZ? AZ is also a scalar H of AM. So OZ equals to A plus H of AM. But what is AM? AM, you get it by AO plus OM. So OZ equals to A plus H into AO is OA. You move AO. So this is A, O. So you move negative A plus positive, that is 3 over the total, which is 7, of OB, which is B. So open this up. OZ equals to A plus H into 3 over 7 of B minus A. When you write this nicely, so OZ equals to A plus, collect A's together. So when you collect A's together and you open up with H, this becomes minus HA plus 3 over 7 HB. So A and A, you can factor A out in this situation. So A into, when you factor A out, becomes 1 minus H plus 3 over 7 of HB. This is OZ. Remember, we have this OZ and we have this OZ. So you equate the two OZs. So this OZ is equal to this OZ. Okay? So from here, this OZ is a third. So OZ equals to OZ. So this OZ is a third T of A plus 2 over 3 T of B equals to this other OZ, which is A into 1 minus H plus 3 over 7 of B, of HB. We are finishing. Then from here, just collect the values of A's together. You bring them together. So this TA, where A is, you take them together. Then this goes with that. So here we will have a third TA equals to, where A is, A into 1 minus H. So A and A cancels, so you remain with a third T equals to 1 minus H. Then the other one, we have 2 over 3 TB equals to 3 over 7 HB. Then B cancels with B. This one A cancels with A. So here you remain with 2 over 3 of T equals to 3 over 7 of H. So remember, we have two simultaneous equations. We have two equations. So we can use elimination method to get the value of T and value of H. So from here alone, we are right to say that H, you bring this H plus a third T equals to 1. From here, just rewrite it. Bring H on the other side, becomes H plus a third T is equal to 1. And then this. So we can make 1 the subject of the formula. Make 1 the subject of the formula. So from here we can replace the value of H. So H equals to 1 minus a third T. H equals to 1, then a third crosses the other side, becomes minus. So you come here, then replace it. Where there is H, you replace by this. So you say this is 2 over 3T equals to 3 over 7, but H is 1 minus a third T. Then open the brackets. This is 2 over 3T equals to 7 times this. 3 over 7 times 1 is 3 over 7. Then 3 over 7 times this, it becomes minus 3 and 3 goes, becomes 1 over 7 T. Then collect T's on one side. So T comes on this side, becomes a positive. So 2 over 3T plus 1 over 7T equals to 3 over 7. So here Get the LCM of this is 21. Then 3 goes into 21 7 times. 7 times 2 is 14. Plus, this goes here 3. Then t equals to 3 over 7. So, this is 17 over 21. T equals to 3 over 7. Multiply by 21, divide by 17. So, t equals, when you simplify this, multiply by 21, divide by 17. So, this 3 times. So, t equals to 9 over 17. So, when t is 9 over 17, what is our h? Just come here and replace value of h. So, h equals to 1 minus a third, but our t is 9 over 17. So, h equals to 1 minus, this when you open it up becomes 3 over 17. So, simplify this, h equals to, LCM is 17, then this is 17 minus 3, becomes 14 over 17. So, our h is 14 over 17 and our t is 9 over 17. So, OZ, from our initial equation, we said OZ, just make a reference, OZ, we just replace it here in our equation. Where there is h or where there is t, you just replace the value to get the value of OZ. Therefore, from here, OZ, so from here, OZ equals to a third of TA, but our t is 9 over 17 of A plus 2 over 3 of our t is 9 over 17 of B. So, OZ equals to 3 here once, 3 here 3 times. So, this is 3 over 17 of A plus, this is going to be 6 over 17 of B. So, that is our OZ. Or you can replace it where there is h, you use the value of h instead of t. It will come up to the same answer as this. So class, this must come in your examination. And because of time, we've already spent time. I have a number of questions here that I'm supposed to revise with you. So these questions, in our next lesson, I'm going to cover these questions on vectors because vectors must come, must be set in your next examination. I want to take this opportunity to end my lesson and to thank you very much for concentrating. And I want to read some of the comments from our people, from Facebook, from YouTube, and from Instagram. And we see how people are reacting. I believe, and I know that most of you have received airtime, some bundles. So this is on YouTube first. We have Kennedy Ochola. You are a great man, bro. We have beloved Jedida. Mimi niko sawa na wewe, ninaenda kupita mtihani. Nice Lemek, thanks a lot Babu, you are doing a great job. Munyao Tom, you should be re-elected and given the youth ministry to empower Kenya's young generation. Inshallah. Abdinasir Ado, I'm too late but I've followed the whole class. I've really benefited. David Masharia, thanks Babu. Nick Wesala, this is man Iniesta. I know this man personally, is a great friend. Thanks Babu. Hey, but you really praised me. This is great. We want you for president. Hey, bado. Time inakuja mbele. So just treat me as your future. We are blessed. So next, and there are so many more, there are many other comments on Facebook. Bernard Basweti Monyoncho, good work for sure. Sultan Sugal, thanks. Israel Moses Okalibong, this is great. Malowa Okuogo, mwalimu amevaa kama minister wa education. Dennis Maina, good job. Korir Albert, excellent job. Jonah Nyona, keep it up Babu. Kaila, I've understood vectors for sure. Cyrus Benjamin, I'll go back for my school fees. Anyway, it's proper. The other friends that we have here, Shadrach Otieno, Okero Natasha, Stacy Okero. I think they are coming from the same family. Great job, Babu. We were tuned in. So this is on Instagram. Very Nevesta. Thanks. Vectors is very nice. I've really understood the concept. Clem_7s akisoma za IG ataquit. Mambo iko sawa kabisa. Kila kitu iko poa. Hata mimi nimefurahia hiyo lesson. Samson Orlando, good work. Clinton Lemushen, hardworking MP, you are the best. Miss Korir, you are the best MP in the world. Thank you. Tusome mambo iko sawa. Mutembei, this is great. I really admire this side of you. Mtu amenipiga vita hapa but ni sawa. Tunawachia Mungu. Anasema Babu yenyewe. Wacha ni wachane na is okay. Now it's positivity. Stewart, congrats. DiCapri 69, I wish you were my maths teacher. I'll be going back for my money. Swale_Swale, comments mambo ziko sawa, nimefurahia sana. So asanteni sana, there are so many comments. So thank you very much everybody and my students, may God bless you. Until we meet again, next lesson will be chemistry practicals on titration, different types of titrations. Stay tuned and we will be doing together with Mr. Gishui. I hope you'll enjoy it. Asanteni sana. Na tuseme we've TBMized vectors and if you like we've TLLized vectors. Thank you.